Hi guys. Turns out one of the problems that I did in chapter 5, number 10, had a bad link. So I'm going to re-record it. So let's begin. Let's see, we're recording. I have to share. I sometimes forget that. And let's go to the link that the student sent me a link to. And it's this one here about probability distributions. Pretty straightforward. And this is the problem. I'm going to ask for a similar question because it seems a little bit cluttered up. Okay, so we have data, and they're asking us to focus on the column about the number of children. Here it is. The number of children is this column here. It seems to go from 0 to 4. Let's open it in Excel. I think Excel might be a bit easier in this context. We'll see why. It gives you the cumulative distribution. So let's open up the file. Open Sesame. There it goes. Okay, so here's the data. Seems to be 30 rows from 2 to 31, which is really 30 rows. The trick is you take 31 minus 2, which is 29, plus 1. So there are 30. I'm going to ignore everything except the number of children. So I'm going to delete it because I don't think we need it later. And we'll get rid of that. What we will need, if you recall from making histograms, is something called a bin. A bin tells the computer how you want to make the categories. In this case, if you look at the question, perhaps go back to it, we need to know how many zeros were there, how many ones, how many twos, how many three, how many fours, and how many were 5 or more. So again, that's done very nicely for you in Excel. You go to, we're going to go 0, 1, and we might as well just pull it down until we get up to 5 even. Let's say 5 or more. Let's now go to data analysis. You have to obviously install that package beforehand. And what we want is a histogram. Now, technically, it's not a histogram because histograms works for continuous variables. This is basically discrete, just 0, 1, 2, 3. We're not talking about 1.2 or 1.27. But you'll see that this works great for histograms as well, for the probability mass function that we need. But first, we got to tell the computer where is the data found, and it's found here to here. Where is the bins found? It's found from here to here. We want, let's use the, oh, go to a new worksheet if you like. We want the cumulative percentage. You'll see why in a minute. That's one of the questions they're asking us about. So let's do a chart output already. Let's hit OK. And this is the relevant data. There were 7 zeros, 11 ones, 7 twos, 2 threes, 3 fours, no fives, and nothing more than 5. These are the cumulative percentages. All right, but what are the percentages? We have to put 7 divided by 30. I guess we can, let's see if we can do that. Insert equals. This is now going to be called the percents. We'll see we'll need that in a moment. So it's going to be equal as a function, not a function, a calculation, equals B2 divided by the grand total of 30, which is 2.33, 23.3% of 0.233. Let's pull it down. Let's change this by right-clicking and format. Oops. Oh, there it is. Format cells. Let's do it to 3 decimal places so it doesn't get too messy. A number, 3 places. And now we have numbers. So 0.233. Let's see what the question asks for. What is the mass function? So this is really the percentages. So 0.233 goes here. The next one is going to be 1. What did I say it was? 367.367. The next one is 0.233 again, because there were 2 of them. The next one is 0.067. The next one was 0.1, I believe. Oh, did I mess up here? Let's see. I think I messed up. 0 is 367, 233, 067. 4 is 0.10. And 5 or more was 0. Let's see if that's right. But yes. Now they ask you to calculate a picture of that. Well, let's see. First of all, it's percentages. So these 2 are wrong. It seems to be 23, then it goes up, then it goes down to the same number, then it goes down, down. This seems right. I guess the answer is A. Correct answer. Well done. Now the cumulative. Cumulative means you had the first number. How many were 0 or lower? 0.233. How many people had 1 child or less, which is 1 plus 0, which is 367 plus 233, which is 5.6. 0.6. But this is found in this column over here. So if we convert this back, so you put the, well, you can do it on your own, I guess, to move over to different places. So it's 0.6. And if you go back to the next one is 0.833. Or you can keep adding these up in your head or with a calculator. We have it here, then 0.90, then 1.00. 0.90. And everybody was lower than 4 or lower. And that means 100% were lower than 5. And we got it right. Oh, there's more yet. Make a picture of that. Well, we have a picture of that. If you go back to the Excel file, it goes like that, but it's hard to tell. We can just look at it carefully. It has to be the first or the second because we're going up. It has to be a percentage, so it has to be A. So let's see, 20%, close to the point. 60. Third one was 83. Yeah, this looks right, so it's got to be A. Wouldn't put my life on it. I wasn't checking that carefully, but we're right. Oh, the probability that an individual has fewer than 3 children, fewer than 3 means we're not including 3. We're going 2 or less. So 0.833 is the answer to that one. That's how many fewer than 3 children. How many had at least 1 child? That means 1 or more, which is everybody except for these 0.233. So you take 100, either add these up or take, I'm sorry, not add up these numbers, or since everything got to add up to 100%, take 100 minus 233, which is taking out my calculator. I'm embarrassed because late at night I'm tired. Where are we? 1 minus 0.233 is equal to 1 minus 0.233 equals 0.767. So this answer got a 0.767. Yes. And finally, I hope it's finally, has 5 or more children? Well, nobody had 5 or more. Nobody had 5 or more. The answer is 0. Are we done? Yeah, we're done. Okay, guys, I'm going to Stop sharing. Good luck. As always, keep those questions coming in.